Identifying the greatest common factor means looking across the entire expression. So here we have three terms and thinking about what's the largest value that we could divide out of each of those terms. And it has to be the same thing. So we want to think about two pieces. One piece is the numerical coefficients. So numerical coefficients are these numbers out in front of each of these terms, so 28 and negative 16. And the second piece is the variables. So let's talk about how we identify the greatest common factor for this expression here. Starting with the numerical coefficients, what we want to do, and I can show some kind of side work here, is we want to think about what's the largest factor that goes into each of these numbers. A good method to use is to list out the factors of the smallest number. So like 8 has the factors 2, 4, and then there's the number itself. 8 is a factor of 8. And with that, then we can look at the other numbers, so 16 and 20, and think about what's the largest of those factors that go into all of those numbers. So 8 works for 8 and 16, but it doesn't divide evenly into 20. So 8 doesn't work. But 4 divides into all three of those numbers. And while 2 does as well, we want to use the largest value. So for my greatest common factor, the numerical portion of it is going to be a positive 4. The greatest common factor turns negative if the leading coefficient, which will be this number at the front, if that's negative, then the greatest common factor is negative, so those go together. But in this case, it's positive, so we have a positive greatest common factor. Now for the variables, that's the other part we want to think about. So what we want to do is identify what variables show up in all of the terms. So x is present in every single term, so with that, we're going to have x as part of our greatest common factor. Our other variable y also shows up in all of the terms, so y will be part of our greatest common factor as well. The piece we need to fill in now is the exponents for these numbers, and what we're going to use is the smallest exponent. So for x, we have 5, 3, 4. So since 3 is the smallest exponent, we're going to have x cubed. For y, we have exponents 3, 9, 2, and with that, the smallest number is 2, and that fills in our greatest common factor. So numerical part, find the largest number that divides into all of the numerical coefficients. For the variables, make sure they show up in every single term, and then use their smallest exponent. So that's how we find the greatest common factor, but then what we want to do is actually factor it out. So factoring means kind of changing things into multiplication. So where this is just, there is multiplication here, but it's mostly these addition, subtraction, we want to create this multiplication of expressions. So what we can do is this 4x cubed y squared can come out front. And what we can do is fill in the blank here for what it will multiply with, and it will equal our original expression. It's just another way of displaying it. Now to figure out what goes into here, we need to think about what happens when we divide out this greatest common factor from each of the terms. So essentially what I want to do is divide this first expression by 4x cubed y squared, the second expression by 4x cubed y squared, and the third expression by 4x cubed y squared. So focusing on this first expression, so 20 divided by 4 is 5. And then let's see, x to the 5th over x cubed, so that'll be x, and then the exponent will be a 5 minus 3, which is 2. Y cubed over y squared, 3 minus 2, which is 1, so y to the 1 power. So here's our first term. And then we'll have plus 8 divided by 4 is 2. X cubed divided by x cubed, those just cancel out with each other. and then y to the 9th over y squared. So we'll have y and a 9 minus 2 for an exponent, which will leave us with 7. Negative 16 divided by 4 will be a negative 4. X to the 4th divided by x cubed, so x, the 4 minus 3 for an exponent, so that'll just leave us with 1. And then those y squared will cancel out with each other. And this is our factored out form. So it's factored in that we have multiplication between these expressions. We took out our greatest common factor, and what that means is that then if we look at these terms inside the parentheses, there isn't anything else we can factor out. There are no common factors between all three of those expressions, and it's because we took out as much as we could at the beginning there. If you're ever unsure that you did this correctly, you can always redistribute. Take that greatest common factor, distribute, and you should end up at the original expression. So they're just two different forms of the same expression. So let's try this with some more examples here. So first piece, finding our greatest common factor. So numerical coefficients of 7 and 8, these don't share any common factors, so I'm not going to have a numerical part of my greatest common factor. I have the variable x showing up in both of the terms, and then I just use the smallest exponent, which will be a 6. So with this, I can factor out x to the 6th, and to think about this, I just need to think about dividing each and every term by that greatest common factor, and then in the parentheses I'll have, I like to call them the leftovers. If we divide out that x to the 6th, this first term will have a 7 left over, and then plus we'll have an 8x, and then for the exponent 12 minus 6, which is 6. And then to check that we've done it right, you could redistribute and make sure you get to the original expression. You also want to make sure that you did in fact take out the greatest common factor, so double check that there's no common factors left inside of the parentheses. All right, big example here. So let's find our greatest common factor. So numerically, we have a 21, negative 14, and a 35. So if it helps, again, take the smaller of the numbers and list out the factors. So we could have 2, 7, 14. And then we could just make sure, which does 14 go into each of these? No, it does not. So that's not the number we want, but 7 does. 7 can divide into all three of those numerical coefficients. So 7 will be part of our greatest common factor. We see x shows up in every term with the smallest exponent being 3. And y shows up in each term and the smallest exponent of 5. So with that and factoring out, we'll be able to have the 7x cubed, y to the 5th on the outside of the parentheses. And then to figure out what's going to be inside, we just think about this division with each of the terms. So with the first term, 21 divided by 7 will leave us with 3. X to the 5th divided by x cubed will leave us with x squared. Y to the 5th divided by y to the 5th is 1. So that's all done. Negative 14 divided by 7 is a negative 2. X to the 4th divided by x cubed will leave us with x. Y to the 10th divided by y to the 5th will leave us with y to the 5th from that 10 minus 5 in the exponent. And then 35 divided by 7 is 5. X cubed divided by x cubed, so those will just cancel out. And then y to the 10th divided by y to the 5th will leave us with y to the 5th. So that's how we can identify the greatest common factor and then factor it out from the expression.